Okay, so this video is to cover some more CAD skills. So these are some skills in Fusion 360. Specifically, we're going to cover sweeping and threading, but you'll notice that there's also a shell in here. So the main skills that you're going to need to demonstrate for this particular lesson are sweep, shells, and threads. And maybe we'll try the loft or the revolve, but those were causing issues. So if you watch the video that's titled Catastrophic Water Pipe, then you'll know why we might back off of the loft and the revolve. I've gotten them to work in the past. I was not particularly successful with them in the demo video that I recorded, but you can check that out. And this video is going to take us through the content leading up to that particular activity. So the deliverables for this particular assignment, what you're going to need to turn into me is a narrated screencast of your water pipe. So not only are you going to show your water pipe in Fusion by screencasting it in PowerPoint, but I want you to narrate it. The screencast must be between 2 and 4 minutes long and should explain the steps you took to design the water pipe. Specifically, your original sketch, why it's at the origin. We'll go over that. We'll do all of this in class as well. How you created the sweep. Try to use the correct vocabulary. So if your sketch is on the XY plane, then your profile that you're going to sweep over the path is going to be on the Z plane. So again, we'll go over that when we design it. How you shelled it and how you threaded the outside of the pipe. And how you created the tapered end, if we are successful in creating the tapered end, which I was sort of successful at in the video. So that's what you will have to deliver. So it'll be a narrated screencast of your water pipe. So first, we'll talk a little bit about the sweep feature. You're going to use the sweep feature to create the main portion of the tube. And what a sweep does is it allows you to extrude a closed profile along a path. So the path may be open or closed. The path itself, the figure that you are sweeping along the path will have to be a closed figure. All that means is that it is... well, here, you know what? That's like way easier for me to show you. So this is a closed figure. That's a triangle, is a closed figure. This is not closed. I think you guys get the idea. So this is closed. That is not closed. So the profile that you're going to sweep along the path has to be a closed profile. And then pretty much what you do is you sweep it along some kind of path, and that path can be open or closed. So they give you an example of a paper clip here. And over here on the right, I'll turn the little pointer on. Over here on the right, you've got the actual paper clip. And then the way that would be designed is in one plane, you would draw the shape of the paper clip. Okay, so that nice like hooking around that we're all familiar with, that would be done in one plane. But remember, for those of you that are in geometry or have already taken geometry, a line doesn't have any width to it. It's got length, but it's got like no depth and no width. It's one-dimensional. So in order to take this and turn it into a three-dimensional object, you have to find a way to make this profile three-dimensional. And the way you do that, or that path three-dimensional, is you take a little circle, you put the circle perpendicular to the path. Okay, so there's a right angle between the paper clip here and the plane. And then we're going to take that circle and sweep it all along that path, and then the result will be the paper clip. So this is a great tool for creating any kind of like pipe sort of feature, which is what we're going to be creating. So that's going to be the first skill that you'll demonstrate. The second one that's new to us is threading. And the thread feature allows you to model threads on cylindrical curved surfaces. An external thread is created on the outside of the cylinder, and that would be something like a bolt. An internal thread is created on the inside. That would be like the threads on a nut. And then what you obviously do as a designer is you'd want to make sure that the outside and the inside threads match each other so that you could screw the nut onto the end of the bolt. So I think that makes sense for most of us. We've done enough with nuts and bolts and so forth there. So you're going to be creating a thread. Those are the two new CAD skills. Now I mentioned earlier that we're also going to be doing a shell and then maybe a loft or a revolve. Maybe you'll see where we have some issues with that. Okay, so I'm going to be giving this to you guys on a handout. This is your drawing of what it is that you're going to be designing. There's one dimension that's missing on it though, and I'll kind of talk through the process for how we'll design this. So we're going to start by drawing like a horseshoe shaped figure in the XY plane. You want your origin to be down at this end. So you're going to start at the origin and then draw some kind of horseshoe shape like this, not including the tapered end. The tapered end was causing some issues. So on the XY plane, it would kind of look like this. I'll turn the pen back on. Maybe I'll turn the pen back on if I can hit the right part of the touchpad. So here's the XY plane. And then we're going to draw something that looks like that. And you'll notice that one end of this water pipe is longer than the other, but you want it to start at the origin. So that'll be our path. Then we're going to draw a circle, and that circle is going to have a diameter of 0.37 inches centered at the end of the path there, and we're going to sweep that along, and that's going to give us our basic shape of our water pipe. Do make sure that you dimension this. If you watch the video, I forgot to dimension it. I had to go back and edit the sketch. Okay, then this is the part that causes a problem. You'll notice that it is tapered here, but there's no dimension given for the taper. So we actually don't know how much that is supposed to be tapered. And they tell you in the PLTW curriculum to make the tapered edge by constructing an axis. So that's my dad. So they have you construct an axis through the pipe and then revolve a shape. If you watch the video, I was able to get that to work, but it does require some pretty advanced geometry where you have to construct a plane through an axis and a point, and then you do have to guess at how much taper there's supposed to be on it. The other way I've constructed the tapered end is by doing an offset plane from the end of the pipe and offset it by 0.25 inches. You can see the dimension there. And then doing another circle of smaller dimension and then lofting from the end of the pipe to the circle. The problem was, if you do watch the catastrophic water pipe video, is that the Fusion would not loft it for me, and I'm not sure why, because I have successfully gotten that to work in the past. So we'll see how that goes. Once we have that, then we're going to shell the entire pipe. And you want to be careful. I think on the video, I tapered it too much, and then Fusion would not let me shell it all the way because my shell was so it interfered with the tapered end, and it basically obliterated the end of the pipe, and so it just wouldn't shell it. And so we'll see if we can work that out. But we can shell the pipe. We want to shell the pipe so that the thickness of the pipe is going to be 1/10 of an inch. So the inner diameter is going to be the 0.27, the outer diameter 0.37, and then we'll put 1/2 inch of 3/8 16 UNC 3A threads on the outside of the one end of the water pipe. When you are done with that, we will go through the design steps in class. Okay, so we will design this together and I'll demonstrate it, but you've got this to look back on. You're going to have the handout with the schematic on it, and you have a reference video, demo video that you can reference if you miss something. If you're absent, you are expected to watch the video posted in the Wakelet as a demonstration. And you can see here I had a few serious issues with the demo video, so I really watch the whole thing before you try to do it on your own, because there are a couple places where I made mistakes and you don't need to replicate my mistakes. Like, make sure that I've worked out my own mistakes first, and then you then try to do the water pipe once you see how that works. If I'm able to work through the issue with the tapered end and the shelling in class, I will post an update on Teams, so please be checking on Teams for any updates if I'm able to work out those issues. I just wasn't able to work them out in the demo video. So as we're doing that in class, we'll see if we can work out those issues, or maybe Fusion will just decide to behave for us. Who knows? All right, so here's the rubric for what you are going to need to turn in. So you're gonna have to submit the screencast, and we did the screencast of the selfie stick, so you are familiar with creating the screencast. This time though, you are going to have to narrate it. So submitting the screencast, 3 points. Time limit adhered to, your screencast needs to be 2 to 4 limits, 2 to 4 minutes. So you do have to adhere to that. You can't be less than 2 minutes. If it's less than 2 minutes, you're probably not saying everything that should be said. If it's longer than 4 minutes, you're probably wasting some time somewhere in there. So practice it first. Your explanation needs to cover the following: the original sketch. So you have to address the original sketch. When you're screencasting it, if you want to do the click back into that timeline and pull up the sketch, click edit sketch, then you can see it. Just make sure that you're not spending too much time on it. You have to go through the sweep. That's a new skill, so that's worth 5 points to explain how you created the sweep. 2 points for explaining how you shelled it, and then 5 points for the threading. That's the other new skill, for a total of 15 points. So we will get as far as we can get with this in one class period, and then we'll take it from there and see if this is a 2 class period assignment. But at the time I'm recording this, I'm not sure. So I hope that gives you a nice overview of what we'll be doing. And remember, if you are absent, you need to watch the demo video and then use the browser version of Fusion to try to work that out on your own.